Just 100 years ago, no one could come to believe that they lived on floating pieces of thin rock. Now, through accurate measurement techniques, we can see how fast and in what directions plates move. Where are these plates moving to? Into the Earth's mantle. Although plates do move around relative to each other, in the shorter term that we can observe, it's more interesting to look at what happens when the edge of the plate interacts. The Cocos Plate resides to the south of Mexico, surrounded by the more commonly known North American, Pacific, Caribbean, and the Nazca Plate. The Cocos Plate is moving northeast into the North American and Caribbean Plate at about 10 centimeters a year. So what is this nonsense about a 30 quadrillion kilogram rock moving? Heat. From the violent beginnings of young Earth and continuing radioactive decay, the inside of the Earth keeps warm. When magma gets heated, just like a hot air balloon, it gets less dense and it rises. When the hot magma rises, it pushes against the hard, cool crust, and where the crust is thin, the molten rock has enough force to push it apart in both directions. You can see the exact same phenomena when baking bread. As the white of the bread gets heated, it pushes against the crust, and where it's thin, it splits apart, pushing it away from one another. Now that the Cocos Plate is moving at a smooth 10 centimeters per year, we can look at what happens when it comes in contact with the North American and Caribbean Plate. Because the Cocos Plate is underwater and is much denser than the other two plates, which are mostly on land, it sinks underneath the North American Plate. These subducting boundaries create volcanoes, including the Paricutin. This volcano is unique because of its very recent correlation with humans. Since the very first eruption in 1943 that generated a 15-meter high cinder cone volcano, it rose up to 424 meters by 1954. Why is the Paricutin where it is? Why is it on the North American Plate 230 kilometers from where the North American and Cocos Plate are colliding? Why can it not be in Tampa, Florida, 2,000 kilometers from the Cocos Plate? Pressure. It happens to be where the plate subducts under another. Most of the time, generates enough pressure to force matter through 30 kilometers of crust out onto the Earth's surface. There's two easy ways of generating pressure. Cram a lot of stuff into a small space, or make the molecules move really fast in a small space. Making stuff go really fast is another term for heat. But why should a subducting plate generate more heat in the already hot mantle? Should it not cool the mantle instead of heating it up since it's coming from the bottom of the ocean? Yes and no. The plate coming from the bottom of the ocean, soaking up all that water, is exactly why it generates so much pressure once it heats up in the mantle. As pressure rises, the melting point of a solid increases. Water gets rid of that effect. Water also gets rid of pesky oxide metals. All in all, the water makes it easier for the crust to melt. When it melts, it wants to occupy a greater amount of space, so it pushes against its surroundings, including the crust above it. Slowly, the material released by the crust and mantle forces itself up through the small cracks, leading the way of a new volcano.